Hey guys, in this video we're going to go ahead and look at example number 1. So here we're asked to find the derivative of y, and that's this part here that I've kind of boxed in. The derivative of y with respect to x, and they tell us that y is equal to this function right here. What I've done is, let me cover this up here, is kind of written out the formula that we had to find the derivative, or to calculate the derivative. And notice that it was written in terms of f prime of x here. But I want you to remember that really f prime of x is the same notation as this right here. So this part right here is interchangeable with any of the notations that we discussed in the previous video. So we have some work to do here. So we're going to start off by first finding this piece right here, this f of x plus h. And so I'm going to go ahead and just do some side work here. And the first thing that I'm going to want to find again is just this f of x plus h, and what that means, let me actually write it out and then I'll kind of say that. But here we have x plus h, and again, all that means is that wherever we have an x in our function, that we're going to replace that with x plus h. In other words, this junk right here that you see me highlighting is going to go inserted, or we're going to insert that into these spots here. And so it's going to look something like this. So we're going to have 2, and then instead of x squared, we're replacing that with this x plus h squared. And then we have plus 3x, so we're going to have plus 3, and then x is going to get replaced with x plus h once again. And then we have minus 1, so minus 1 there. Okay, so now we just have to kind of clean this up a little bit and do a little bit of algebra, and that shouldn't be too bad to do. So I'm going to drop down to 2, and I'm going to expand this. This is really x plus h squared, so that means that we're going to have x plus h times x plus h. Here we're going to have plus. Now I'm going to go ahead and distribute this. So 3 times x and then 3 times h. So I'm going to take care of that already. So 3 times x gives us 3x, and 3 times h is positive 3h, and then I'm going to drop down to minus 1. So it looks like the only thing that I need to take care of now is just this part here. So I'm going to leave the 2 alone. I'm going to drop down to 2, and I'm going to go ahead and just multiply this junk out right here that we see. So this is going to turn into, let's say, x times x, which is x squared. Then we're going to have x times h, which is just, I guess, xh. And then here we have h times x, which is hx. However, since I've already written xh, I'm also going to write xh again. So I'm going to keep it the same order. And then we have h times h, which is h squared. Okay, so that's that inside part. I'm going to close the parentheses. Now I'm just going to drop down all this other stuff here, this 3x plus 3h minus 1. So we're going to have plus 3x plus 3h minus 1. Okay, kind of trying to squeeze that in there. Then I'm going to distribute the 2. But before I distribute the 2, I notice that I have x plus h, or I'm sorry, I have xh plus xh. So that's going to give me 2xh. And now what I want to do is maybe distribute that 2. So let's try and do that. So again, we're going to have 2 times x squared. That's going to be 2x squared. And then we're going to have 2 times this junk right here, which ended up being 2xh. So 2 times 2 is just a 4. So we're going to have 4 xh's. All right. Then we're going to multiply 2 times h squared, which is going to be, let's see, 2h squared. Then we have this stuff that we're going to bring down, plus 3x plus 3h minus 1. Okay, and again, forgive me for trying to go off the paper here. I'm just trying to squeeze it all in. But I think that's it. I don't think we have any like terms sitting here. Notice that I have an x squared. Nowhere else in this statement do I have an x squared. I have xh, and nowhere else do I have an xh. I have h squared, and again, nowhere else in here is an h squared. And here we have an x. Now here we do have an x, but this is really xh, and this is just an x, so this is not, these are not like terms, so don't get confused there. But it turns out that that's pretty much it. So that is our f of x plus h. So let me actually write that in. This is really equal to f of x plus h. All right, so we're going to use this expression here in just a moment. Okay, so we found that part already, so I'm going to check that off. Next thing is that we need to know, well, what is f of x? That's pretty easy. If you think about it, f of x is just your original function that they've given us, which is f of x. Now here's the only catch. They don't just want positive f of x. They want, let me scoot the paper down a little bit, they want negative f of x, right? So minus f of x. So here we have, I'm going to write this out, that f of x is really 2x squared plus 3x minus 1. But they want negative, or they want the minus f of x version of that. So think about what we just did. We multiplied this by a negative. That means that I have to multiply all of this junk by a negative. So 2x squared times a negative is negative 2x squared. 3x times a negative is negative 3x. And then negative times 1 is positive 1. And so here is the negative or the minus f of x part. So now we have the whole part of the numerator. We have the f of x plus h, which is sitting right here, and then we even have the minus f of x, which is just sitting right here. So all we have to do now is just write this entire statement and this entire statement in place of the numerator and then calculate the limit, and I think we're done here. So let me see, we're going to drop down, keep this in red, we're going to drop down the dy dx, which again is the derivative of y with respect to x, and that's going to equal the limit of h sub 0, and then here is the fraction bar. For the denominator, nothing is really changing, it's still h. Now for this f of x plus h part, we are going to go ahead and write what we calculated here. So we're going to have, let's see, 2x squared plus 4xh plus 2h squared. Okay, and then plus 3x, plus 3x plus 3h minus 1. Okay, that itself is just this piece here. So it looks like I need to make my fraction a little longer, but that's all right. Then we got to write the minus f of x part. Well, minus f of x is all taken care of for us, or it's taken care of for us here. So here we're going to have minus 2x squared. We're going to have a minus 3x, and we're going to have a positive 1. Okay, so then all we have to do now is just kind of see if anything cancels here. And if you look very carefully, it looks like we're going to have, let's see, I see the 2x squared minus 2x squared cancels. I see a positive 3x and a negative 3x. And I even see a negative 1 and a positive 1 cancels out. And it looks like that's pretty much it that cancels out. So let's just write what's left over. So here we're going to have, again, dy dx is equal to the limit as h approaches 0. And let's see what's left over in the numerator. We're going to have 4xh plus 2h squared plus, let's see, 4xh plus 2h squared plus 3h. And this is, again, all divided by h. So now what I want to do is cancel out this h that's in the denominator. I need to divide that out. So I'm going to go ahead and factor out an h from the numerator because I noticed that they all have an h in common. And that'll look something like this. So again, just dropping this stuff down. All right, so let's see what it's going to look like. They all have an h in common, so I'm going to take that h out. And I got to figure out, well, what's left over. Well, if I take the h out from here, we're going to be left with 4x. Here I had 2h squared, so when I took out 1h, or when I factor out 1h, I'm left with just 2h. Here, when I take out or factor out this h, all that's left is a 3, and then this is going to be all divided by h. Now, the cool thing here is that now our h's cancel out. So here, the h's are going to go ahead and cancel out. They're going to divide out. And now we just have this limit to evaluate. And so if we evaluate this limit, let's see, let me keep the colors the same. So we're going to have dy dx is equal to, let me just write what's left over, and then we'll calculate the limit here. I'm left with 4x plus 2h plus 3. Now here, h is going to 0, so we're going to go ahead and plug in 0, and so we're going to end up getting, let's see, 4x plus 2 times 0 plus 3, and then this is going to lead to 4x plus 3. And again, I'm just going to drop down the derivative of y with respect to x. And here is the derivative as a function. Now, the benefit of having it written this way, in terms of having it written at a point, is now I can ask you, what is the derivative at x equals 0? Well, you would simply now plug 0 into the derivative function, and you would get out a number. I could also ask you, what's the derivative at x equals 5? And now you could plug in 5, and you would say, oh, it's 4 times 5 plus 3, and you would say 23. And so now you can calculate the derivative at any point that interests you, or any point that is of interest in the problem. And so this here is the derivative as a function.